Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a problem number 5, which is based on solution of differential equation using inverse Z transform. So first of all, in last numerical as well as current and next numerical, we are going to solve a numerical which is completely based on ZIR, ZSR and total response. So we'll start a problem number 5 first. Problem number 5. Obtain the output response of system which is given by this differential equation y of n equals to x of n plus 2 x of n minus 1 plus 0.5 y of n minus 1 plus 0.2 y of n minus 2, and some initial values are also given for y of n minus 1 is 0 and y of minus 2 is equals to 1. Now here in x of n, that is in input, the u of n is mentioned. U of n is available only for a causal sequence, or you can say that amplitudes are available only for a positive instant of time, and for negative instant of time amplitude is always 0, which means if we are going to calculate the x of minus 1, then that x of minus 1 value is considered as 0, or we have to consider it as 0. Now we'll apply a Z transform, that is one-sided time shifting property of Z transform on this question. So we will apply a one-sided or unilateral Z transform property, or you can say a time shifting property of Z transform on this question. So before moving to solution, first of all we should know the property statement of one-sided time shifting property of Z transform. Basically it is classified into two parts. First property is for a time delay and second is for time advance. Now the first formula is for time delay. Here the Z transform of x of n minus k, that is here the function is delayed by a minus k. Now as the function is delayed by minus k, so I have multiplied this whole bracket by z to the power minus k. Look at here in time advance. Here the function is advanced by plus k, so I have multiplied this whole bracket by z to the power plus k. Now we'll move inside this bracket. Now listen, first one is x of z, that is the Z transform of original function, and then we are going to add some delay value, or we can say that we are going to substitute some values of n, which is varied from 1 to k. This k is nothing but the delayed amount or delayed value, and that will be substituted inside x of minus n and z to the power n. We are going to place all this n value over here. Now look at here in time advance. The formula is x of z minus summation of n to the power 0 to k minus 1 x of n into z to the power minus n, which means here we are going to substitute all the values of n over here. Now in my question all the functions are delayed, which means I'm going to use this delayed function formula. So look at here, this is our question and these are some initial condition values, and this was my input value, which is 2 raised to the power n u of n. And look at here, I'm going to use a time delay property of one-sided or unilateral Z transform. This is the property because my all the x of n and y of n's, or you can say some x of n and y of n's are delayed by some value. Here x of n is delayed by 1, whereas y of n is delayed by 1 as well as 2. Now we will apply this formula over here, but how? First of all we will use a statement. We are going to apply Z transform on both the sides. So Z transform of y of n is represented by y of z. Next x of n, Z transform is x of z. Now here the 2 is a constant, so I'll write first and then we will use this formula. Here the function is delayed by 1, so we will replace all the k values by 1. So first of all we'll place here a minus 1, that is z to the power minus 1. The first one is here the function is x of n, that's why we can write x of z. Now here the k value is 1, so we are not going to use this summation value. We will directly substitute this n value in our bracket, so I can write all the n replaces by 1. Now we will move on to next. The next function is y, so first of all we'll write the constant value, which is a 0.5. Then y of n minus 1, here the function is delayed by 1, so we can write z to the power minus 1. The first one is y of z, and then we will use this remaining part because here n value is 1, so we'll directly use, or we'll directly substitute n value as a 1 in both this part. So This will be my result for 0.5 y of n minus 1. Now the next one is 0.2 is a constant. Here my k value is 2, so we'll write z to the power minus 2. Now basically, as I said in time shifting property also, while applying time shifting property, if the function is delayed by some value, then directly place that value with a sign in the power of z. So here the function is delayed by minus 1, that's why I have placed minus 1 in the power of z. Here also the function is delayed by minus 1, that's why I have placed minus 1 in the power of z. Here the function is delayed by minus 2, so look at it, I have placed minus 2 in the power of z. Now next one is according to formula. First of all, we will write the z transform of y of n, which is y of z. Next we will use this formula, but here k value is 2, so we'll use this summation where n value varies from 1 to 2, and then next y of minus n z to the power n. Now what I'm going to do, I'm going to substitute this n value inside this bracket or inside this y of n function, and then after that I'll substitute all my constants or initial values in that solution. Now look at here, I have opened this last summation bracket, so I've substituted my value of n from 1 to 2. So first of all I have substituted my n value, which is 1, and then after 2. Now what is my condition? Just multiply this all the 2z inverse, 0.5 z inverse or 0.2 z inverse inside this bracket. So what you will get, 2z inverse is multiplied with x of minus 1 into z. Now look at here the power of z is minus 1 and here the power of z is plus 1. So if the bases are same, then always powers gets added. So 1 minus 1 becomes 0. So z to the power 0 is always 1. So we'll write only 2 into x of minus 1. Now next one, similarly we'll multiply this 0.5 z inverse inside this bracket. So first term is 0.5 z inverse into y of z. Now again look at it, here we have the power negative order of z, which is minus 1, and here the order of z is, or the power of z is plus 1. So again we'll get the same answer. If the bases are same, then powers always get added. So here the power is 1, here the power is minus 1. So after adding 1 with the minus 1, you will get a 0. So z to the power 0 is always 1. So you will get the answer, which is 0.5 into y of minus 1. Now we'll multiply this 0.2 z to the power minus 2 inside this bracket. The first term is 0.2 z to the power minus 2 into y of z. Now the next one, this z to the power minus 2 and z to the power plus 1. So one order of minus 2 will get removed. So you will get, after multiplication, our result is, as I said, here the order is minus 2 and here order is, or power is plus 1. So minus 2 plus 1 answer is a minus 1. That's why I've written z to the power minus 1. Now if I multiply this 0.2 z to the power minus 2 with this one, so z to the power minus 2 into z to the power plus 2, the bases are same, so powers always get added. So 2 minus 2 becomes 0, so z to the power 0 is always 1. So after multiplying, what you will get, 0.2 into y of minus 2. Now basically what I'm going to do, I'm going to shift all y of z terms on left hand side so that I can take y of z common, and then after I'll substitute my all initial condition value in my solution. So first of all I'll shift all the y of z terms on left hand side. So y of z minus 0.5 z inverse y of z, then this one is also shifted to left, so minus 0.2 z into the power minus 2 y of z. Now on left hand side, what we will get, this x of z, and x of z I can take common, so you will get 1 plus 2 z inverse. Now x of minus 1, x of minus 1 means what, the basically the value of unit step. In question the x of n value is already given, which is a unit step function, and in our question the x of n value is given, which is a unit step. Now if I substitute n equals to minus 1 in this formula, then what you will get? X of minus 1. Basically, unit step is a causal function, or you can say that amplitude of unit step is available only for a causal sequence. So minus 1 is in a non-causal time. 1 is a non-causal time, and the amplitude for unit step function at minus 1 is always 0. So the product of whole term is also 0. So I can directly substitute x of minus 1 as 0. So 2 into 0 is 0. So I'm not going to write that value. We'll move on to next. So this whole value is replaced by 0. Now the next one. Here the 0.5 y of minus 1. Now in our question, the initial condition value y of minus 1 is given, which is 0, and y of minus 2 value is given, which is 1. Now I'll substitute both this value in our solution. So minus y of minus 1 value is 0. So 0 into 0.5 is also 0. So this value shifted on left hand side, so we are not going to write this. Next we'll move on to, again we have y of minus 1, and y of minus 1 is again 0. So 0 into whole term is again 0. And the last term is 0.2 into y of minus 2, and y of minus 2 value is given, which is 1. So 0.2 into 1, answer is 0.2. So look at here. Basically, if in our question it is mentioned find ZIR and ZSR, that is zero input response and zero state response, then this A part gives us a zero state response, and this 0.2 output is obtained just because of initial condition. So this 0.2 output will gives us a zero input response. But in this question, what we want, we are going to calculate a total response. Total response means what? We are not going to separate these two parts. We'll consider this one as a whole output, and then we'll solve whole solution together. Look at it. I have taken y of z common from left hand side, so I have got this equation, and on right hand side we have got this one. Now x of n value is given in our question, and x of n was the x of n is 2 to the power n u of n. So here we want x of z. So if we apply z transform on this function, then we can write a raised to n u of n, that is we can use a time scaling property over here, and according to time scaling property my answer is always this. So we'll substitute this whole value over here. Now I'll multiply z minus 2 over here, or you can say just do the cross multiplication. So on left hand side I'll have this equation as it is, but on right hand side what we will get? Z into 1 minus z inverse plus 0.2 z minus 2 upon z minus 2. Now I will shift this whole product term, which is multiplied with y of z, on right hand side. Now multiply this z inside this bracket. So what we will get? Z plus, we can write only 2 because z here we have order 1 or power 1. So if this z is multiplied with z to the power minus n, so z bases are same, so powers always get added. So 1 minus 1 becomes 0. So z to the power 0 is 1. That's why I've written only 1 or 2 over here. Now I'll multiply this 0.2 inside this bracket. So what will get? A 0.2 z and 0.2 minus 2. Answer is 0.4. And in denominator, z minus 2 is multiplied with this whole left hand side part. Now z plus 0.2 z, answer is 1.2 z, but 2 minus 0.4 is 1.6. Now in my next step I'm going to change this numerator, as well as you can convert this whole question into a positive order of z or positive power of z, or else you can convert this whole function into a negative power of z. I'll solve this whole function by considering or by calculating all the z's in negative powers. Look at here, I have added all the coefficients of z and z to the power 1 as well as z to the power 0. Now as I said, we can convert this whole function into negative power of z or a positive power of z. So my solution will be, or I'm going to solve this whole question by considering or by calculating z in negative powers. So here I can take z common from numerator as well as from this first bracket. So these two equations will be, now from this numerator I have taken z common, so the first term is 1.2. From these two parts I have taken z common, so this will be represented by this, and the last part remains as it is. Now I can say that this z get cancelled, so this will be the next result. Now in our question it is mentioned we are going to calculate the output response, and to get the output response we are going to apply inverse z transform on y of z. But if you look at here, this function is not transformed or directly transformed into a z. So first of all we'll use a partial fraction method so that we can directly use the inverse z transform on the solution. So first of all, according to partial fraction, we will factorize this denominator. So these are my two factors. Now if we have a three factors in denominator, then of course we will use three constants. So let's say my first constant is a. In the denominator of a, I'll write 1 minus 2z inverse. Next one is b, and last one is c. Now just do one thing, I'll multiply this left hand side denominator on right hand side, but before of that I will mark this one as my equation number 1. Now after multiplying this left hand side denominator on right hand side, what you can say, this 1 minus 2z inverse, 1 minus 2z inverse get cancelled, so a will be multiplied with these two products. Now 1 minus 0.762 z inverse will get cancelled, so b will be multiplied with these two terms, and in c, this 1 plus 0.262 z inverse will get cancelled, so c will be multiplied with these two terms. So after multiplying, what I will get, now this is nothing but my equation number 2. Now I'll substitute z inverse value such that I'll get all the constant value one by one. I want to calculate a value for a. So look at it, which bracket or which term is missing over here? 1 minus 2 z inverse. So if I substitute z inverse equal to half, then I can say that 2 and 2 will get cancelled. Over here also 2 and this 2 will get cancelled, so what will get 1 minus 1, here also will get 1 minus 1, and 1 minus 1 becomes 0. So 0 into anything is always 0. So whole b term and whole c term, or you can say whole b product term and c product term is replaced by 0. So I'll substitute z inverse equals to half in my whole equation, or you can say my equation number 2. So this z inverse is replaced by half. Now these two also replaced by half, and plus I can write 0. Now one will solve this left hand side, and I'll solve these brackets, and then you will get the answer of a. So after solving whole bracket, what I've got this result 0.7. Now if I shift this 0.7 on left hand side, then I can write my a value is 2 by 0.7, and if we solve further, so I can write this one is 20 by 7. If you want, then you can write this answer in fraction also, but I'll consider the ratio part. Now we will substitute another z inverse value to get the value of b. Now look at it, which term is missing over here? The answer is 0.762. So if I substitute z inverse equal to 0.762, then automatically 0.762 will get cancelled, and this whole part is replaced by 1. So 1 minus 1 becomes 0, so automatically my a term and as well as my c term gets vanished. So I'm going to substitute this z inverse equal to 1 upon 0.762 on both the sides. Now as I said, my whole a term and b term, now as I said, my whole a term and c term is replaced by 0. So I'm going to write only equation for b. Now I'll solve left hand side part as well as a right hand side part one by one. So after solving left hand side part, I have got 3.299, and solving the right hand side, I have got minus 2.183. Now I'll shift this minus 2.183 on left hand side so that you will get the answer of B minus 1.511, or else you can write only minus 1.51. Now similarly we will solve value for C. Now we'll calculate the value of C. So we'll substitute Z inverse equal to perfectly missing part. Here the missing term is 0.262. So if I substitute 1 upon a minus of 1 upon 0.262 in our equation, why we have substituted a minus sign? Because all the 0.262 is having a plus sign. So if I replace this sign by minus, and if 0.262 0.262 will cancel, so automatically 1 minus 1 becomes 0. So my A term and B term both are replaced by 0. So we'll get the answer only of C. Now look at here, I have replaced all the A term and B term product term by 0, and now I'm going to substitute a value of C. So now I'll solve this left hand side part as well as this right hand side part one by one. So after solving this left hand side part, what I've got minus 4.907, and after solving this right hand side part, I have got 33.74 multiplied with C. And now if I shift this 33.74 on left hand side, what will you get? C is equals to minus 0.145. Now I'll substitute all the values of A, B and C in my equation number 1. So look at here, I've substituted the values of A, B and C in my equation number 2. Now next one, what we want, if we want to convert or if we want to apply inverse Z transform on this function, then it is necessary to have one Z in numerator. So what I can do, I'll multiply numerator and denominator by single Z. So I'll write constant term first, and if I multiply numerator and denominator by Z, so in numerator we will get Z, and this part 1 is replaced by Z, and we'll get only a minus 2 because Z is multiplied Z to the power minus 1. So already this Z is having positive power, this one is having negative power, bases are same, so powers always get added. 1 minus 1 becomes 0, so Z to the power is 0. So we have only Z minus 2 in the denominator. I'll write this constant part first, minus 1.511, and as the Z multiplied in numerator and denominator, so you will have this equation. Similarly here also I'm going to multiply Z. So first of all I've written a constant term first and then this. Now we can apply inverse Z transform on this equation. Now we will apply inverse Z transform on this equation so that you will get the output response or total response of system. So by applying inverse Z transform both the side, this y of z can be written as, or basically we can write it as y of n. Now first of all the constant term which is 20 by 7. Now z upon z minus 2. Here my a value is 2, so I can write 2 to the power n into u of n. Again the constant term which is 1.511. Now this response is obtained just because of, you can say, 0.762 raised to n into u of n, and the last one, that is minus. Now here my a value is minus of 0.262 because what we want to write this equation like z upon z minus a. So if I take a minus sign common for 0.262, then this equation can be represented by, or can be written like this: z upon z minus, inside this bracket, minus of 0.262. So my a value is minus 0.262, so I can write minus 0.262 raised to n into u of n. Now look at it, this is our solution, but if you want to move further, then you can take u of n common. So after taking u of n common, what you will get? 20 by 7 into 2 to the power n, then minus 1.511, and this is nothing but our result, or you can say the output response or total response of system. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.